Hi and welcome back to our video roundup. I'm Katrine Brahick and I'm here to take you through this week's Best Science videos. First off, we've got some fashion-conscious birds. Researchers from the University of California in Santa Cruz have discovered that female lark buntings look for different attributes in their mates from year to year. Over 5 years, the team looked at whether male traits like big beaks or bright feathers were hot or not with the females. This female was used to lure in the wild males so that the researchers could watch them in action. Don't be fooled though, she's actually stuffed. It seems like different characteristics come into vogue each season based on social or environmental changes in the area. So for example, a male with protective features might be fashionable in a year where there are lots of ground snakes around. Previously, researchers thought that female lark buntings were a little bit more consistent in their tastes and that certain traits would always be popular. In our next video, we look at face recognition systems and a simple way of dramatically improving their performance. Technology editor Will Knight takes us through it.
Many of us will claim that our passport pictures don't look a thing like us, but our friends and other humans are able to recognise us despite the unflattering angle. Face recognition systems, however, find it harder to identify a match when a bad picture is submitted. Psychologists from the University of Glasgow wanted to see if they could increase the system's accuracy by submitting images that were the average of many photos of the same person. They used sets of 20 celebrity photos from an image database, like these of actor Jack Nicholson. When submitted individually, the system correctly identified 54% of the images, but when average images were submitted, the success rate reached 100%. They also tested the system with photos that were not correctly identified, creating an average image from these. From 0%, the success rate rose to 84%. Thanks to this technique, machine recognition systems could soon compete with humans.
While those scientists are trying to get software to perform more like humans, another team is looking at how a swarm of robots could morph into a human-like form. Tom Simonite tells us more.
Ants aren't very bright individually, but a whole colony of them is capable of very complex things. Swarm robotics aims to perform the same trick using groups of simple robots. Researchers at Carnegie Mellon University hope to build swarms of tiny robots that can shapeshift into anything, even a car or a copy of a person. For now, they are working out how such a swarm might be controlled and experimenting with ways to physically connect individual robots. These prototypes use a ring of electromagnets on their edge to grab hold of other robots and move around. The same magnets can be used to share power or sense their environment. Another prototype uses electric forces instead. Electrodes charge up the surface of this star-shaped attachment with static electricity, making the stars stick to those that are oppositely charged. Once the charge is built up, no power is needed to keep the connection and hold them together. The team hopes to experiment with up to 100 of the cubes, and they think that the electric charge approach will be more efficient at microscopic scales.
More swarms now as Sandrine Kirstemont tells us how bees pick a new home.
When bees move house in the spring, thousands of worker bees cast votes to choose the new home. Half of the colony forms a swarm and several hundred bees are sent off house hunting. Researchers from Cornell and Ohio State University tagged swarms of bees to keep track of those that went on house viewings. Computer simulations were used to see how findings were communicated to the group. They found that scouts did waggle dances and ran across the cluster, increasing the number and intensity of runs when they found a high-quality site. Scouts danced to recruit other bees to come along with them and check for themselves. The recruits then do their own dances when they return to the swarm. Eventually, one site wins a threshold number of votes, and the swarm makes its decision. This process resembles the way neurons communicate in a vertebrate brain.
And that's all for now, but there are plenty more science and tech stories on the website, or you could always buy the magazine. See you next week.